Hello, Math 10C. We are now in lesson 5, and as you can see, we're just a quick recap of what we've done. In lesson 5, we are just really recapping and taking it one step farther. We learned how to calculate the lengths of sides. We learned to use Pythagorean theorem with trigonometry, and in lesson 4, we learned how to find angles. And in this lesson, all we're really going to do, the learner outcome here is now we're going to do something called solving a right triangle, and we'll talk about that in a minute. But we're basically just combining those skills of finding sides and finding angles. So I want you really to just use these first couple of examples as just a review of what we've done. I'll do the first one with you, and then I want you to carry on and do the others, and we'll come back and look at the answer. So again, we're standing at x, so that means this is the opposite side, this is the adjacent. The equation to solve for the angle is tangent of x degrees is equal to 12.7 divided by 5.2. I type inverse tangent, I don't have to write this, you guys, but I type inverse tangent of 12.7 divided by 5.2, and therefore, please put x is equal to, therefore, x is equal to, in this case, and so x equals 68 degrees. And remember, nearest whole number, that's why we rounded it to that. In the second triangle, I'm standing here at 24 degrees. Therefore, my ratio would be tangent from 24 degrees is equal to x over 68. And therefore, x is equal to tangent 24 times 68. And so x is equal to 30 to the nearest whole number. In the next example, I'm standing at 69, and so therefore my ratio from that position would be sine from 69 degrees is equal to 126 over x. And so when I solve for x, I get x is equal to 126 divided by the sine of 69, and so that ends up being x is equal to 135. Finally, in D, standing at D, standing at x, I'm looking for x, so cosine from x degrees is equal to 4 over 7.2, and therefore x is equal to, in this case, 56 degrees. Remember, what do you need to show for work? I need to see your equation, your equation, your equation, your equation, and then I need to see your answer. All right? And that's the key part. Remember, in terms of feedback, do not put equal to 68. That is silly. People will laugh at you. You do not write math statements because that fraction doesn't equal 68. X equals 68. Okay, continuing on, I want you to draw a diagram for the next question and then answer the question involved there. So as you can see, you need to draw a diagram. So the pole was 11 meters tall. There's the pole, telephone pole. Pole was 11 meters tall. It's 13 meters from the ground, making the equation to find the angle between the wire and the ground. Again, we are dealing with, now hold the phone. Let's see. Did I put that in the right place? The wire is 13 meters. No. So 13 meters doesn't go there. 13 meters goes here. So the equation should be sine from x degrees is equal to 11 over 13, which therefore makes x degrees to the nearest degree. Let's check a rounding. Nearest degree, x degrees is equal to 58. Now we can find the distance between the point on the ground and the foot of the pole, so they want this distance. I'll call that distance d, and I want to find that in two ways, Pythagoras theorem and trigonometry. So with Pythagoras theorem, please write Pythagoras theorem, d squared plus 11 squared is equal to 13 squared. That's how Pythagoras would write it. Therefore, d squared is equal to 13 squared minus 11 squared. That makes d squared equal to 48. So d is equal to the square root of 48. That's the exact value which we wanted it to the nearest 0.1. It works out to be 6.9. From trig, we can do it with trig using the 58 degrees, and I could use several different ones, but I think what I'll use is, with trig, I'll use, I guess I'll use tangent. Tangent from 58 degrees is equal to 11 over d, and therefore d is equal to 11 divided by tangent 58 degrees, and that ends up being equal to 6.9 meters, and I should have put meters there. Okay, so we can use either method. Remember what we talked about, don't use answers that you rounded off if you don't have to. So really, this is the better answer because this answer isn't rounded off, right? That was used by Pythagoras' theorem by those two sides, okay? In the next question, you are supposed to, so in this question we're going to talk about solving triangles. What does that mean? To solve a triangle means that we have to determine the length of all the sides we don't have and the measure of all the angles. In addition to the right angle, we need to know the length of one side and one other piece of information. What tools do we have? We can either use Pythagoras' theorem, which we've learned and remind ourselves, but you can also use trigonometry. So you just need to decide which one to use and how. So there really isn't anything new here. It's just about you using your skills in different ways. Okay, so look at the triangle. What are we given? We are given this angle. We are given this side. What I'm looking for, and I want you to put letters for this. Remember how we talked about naming? What side is this? This is little c. Why? Because it's opposite the capital C. This is little a. So let's make a list of the things we're supposed to find out. All answers correct to the nearest whole number. So I want you to put some little vertical bars to separate this. So I've got 3 things I need to find out. And I'm going to organize my work. I've got to find out, and I'm going to highlight those things. I've got to find out this angle here. I have to find out this side, and I have to find out this side. Everything else I know. So let's put those things down on my chart. I've got to find out little c, that side. I've got to find out little a, that side. I also have to find out angle C, or if you want to use 3 letters, you could call it angle A, C, B, whatever you want, okay? What will I use to find out C? Well, I can't use Pythagoras' theorem because I don't have 2 sides, so I need to use trig. In order to find C, we've learned that, well, I'm going to have to use cosine. Cosine from 37 degrees is equal to C over 33. C equals, in this case, C equals 26. In the next one, I have to find out little a. Little a, how do I find little a? Well, I'm going to have to use the equation sine from 37 degrees is equal to a over 33. Opposite over hypotenuse. Therefore, a is equal to 20. And lastly, I need to find out what is the angle C. Well, you could use trig, but really you know that this angle and this angle have to add up to 90. So we know that angle C plus 37 degrees equals 90 because you've already got 90 used up. So that means that angle C is equal to 90 minus 37. They're complementary angles. Angle C is equal to 57 degrees. Done. Sorry, 57, silly. Not 57, 53. And that's how the cookie crumbles, okay? So in the next one, I want you to fly on your own and solve the triangle. But now, careful to always underline, this needs to be to the nearest tenth, and all angles need to be correct to the nearest whole number. So sides to 1/10 and angles to the nearest whole number. Off you go. Remember, organize your work so you know the pieces you're trying to find, and do that first, okay? So people can see your work. So what were we trying to find in this one? If you label things in the triangle, you were trying to find capital D. You need to find an angle D. You also needed to find angle F, and you're needing to find side E. Use Pythagoras' theorem, use trig, find those elements. What did you see? Well, hopefully you saw this. To find angle D, you would have used tangent D equals 4.9 over 5.3. Angle D is 43. Now, if you want, you could Now subtract 43 from 90 and get 47. Now notice this guy is scared. Why is he scared of that answer? Well, if you get this one wrong, you now have this one wrong too, because they're dependent on each other. So another way to do it might be to use trig again, and now from angle F, tangent would be 5.3 over 4.9. And if you do that, you'll see that, yes, you do actually get 47 degrees, but this is maybe the safer way. Blue is maybe safer because you're not relying on your previous answer. And lastly, looking at side E, you've done that in grade 9. E is equal to, E squared equals 4.9 squared plus 5.3 squared. That's Pythagoras' theorem, and you are ready to complete your assignment for lesson 5.